My name is Sechanze Elvis, Computer Science. Student's number is 2300726152 and my registration number is 23/U/26152/PS. I'm going to briefly explain the history of development of computers from the first generation to the latest development. Here we come as computer generation is the development of technology, of computer technology. Computer generation is the development of computer technology over periods of time. Here we have the first generation, which is from 1940 to 1956. These computers basically used vacuum tubes and the thermionic valve machine. The computers in the first generation, their input system was based on punched cards and paper tape. However, output was due to printouts. They worked on a binary code concept that is from 0 to 1. And examples of computers in the first generation will include ENIAC, EDIVAC, UNIVAC, IBM 701, among others. These computers were characterized by consumption of a lot of heat, they produced a lot of noise, and they consumed a lot of power. They were large in size, among others. We have those of the second generation. The second generation computers, they were from 1956 to 1963. These computers were developed with the use of transistor technology, and their size was smaller than that of the first generation. These computers consumed lesser heat than that, consumed lesser power than that of the first generation. They consumed lesser time in terms of output. These computers used magnetic core technology, which was used as primary memory, and magnetic tape disks were used as secondary memory. These computers also used assembly languages such as COBOL and Fortran. They also used batch processing and multi-programming operating systems. Computers in the second generation were characterized by being reliable. They were reliable in comparison to those of the first generation. These computers supported both machine code and assembly languages. And computers in the second generation included IBM 1620, IBM 7094, CDC, among others. Here we go to the third generation computers. These computers were from 1963 to 1971. The computers of the third generation were from 1963 to 1971, and this is the period of development of computers. And these were developed using integrated circuit technology, and their size was far more smaller than that of the second generation and the previous generations. And they also consumed lesser power in comparison to those of the previous generations. Their maintenance costs were low, and these computers used a multi-programming operating system, and they were very good for commercial purposes. They also used high-level languages such as Fortran 2.4, COBOL, Pascal, BASIC, among others. The computers in the third generation were characterized by consuming lesser space. The amount of heat had reduced in comparison to those of the previous generations. These computers' maintenance cost was very low in comparison to that of those previous generations, and they supported high-level languages such as IBM 8600 series, among others. Computers in the third generation included DP-TDC, among others. There comes the computers in the fourth generation, which was a period from 1972 to 2010, and these were developed by the use of microprocessor technology. These computers in the fourth generation were far more portable than those of the previous generations, and they gave out an outlet of low heat. In fact, they accumulated lesser heat than other previous computers in the previous generations. These computers were much faster and accurate in terms of bits, and their costs reduced in comparison to those of the previous generation. And these computers also became available to even a layman or an average man due to the costs involved in their consumption. The computers in the fourth generation used very large-scale integrated circuits, and this VLSI having about 5,000 transistors and other circuit elements with the associated circuits on a single chip. They were more powerful, compact, and reliable and affordable. That's why it's of the PCs. High-level languages were used such as C, C++, DBase, among others, and computers in the fourth generation included DEC 10, Star 1000, PDP-2, and Cray-1. These computers were characterized by being small in size. They even needed no AC to cool out the heat they produced. Since they produced lesser heat, they consumed lesser power, and they were far more faster than others. They were very portable, to mention but a few. There comes the fifth generation, which was from 2010 to date, and this included comparison of software and hardware as in comparison to those of the previous generations. The VLSI technology became more rampant, and it was replaced by the ultra-large-scale integration technology. Thus, microprocessor chips having 10 million electronic components embedded in them. They were based on parallel processing hardware and artificial intelligence software, and all high-level languages such as C, C++, Java, .NET, among others, were used in this generation. The computers in this generation were characterized by use of USLI technology, the ultra-large-scale integration technology. These computers they were artificially very intelligent as compared to those of the previous generation. Natural language processing was also used in these computers, and the advanced parallel processing. Computers in this generation will include laptops, notebooks, desktops, among others. I'm going to briefly explain the evolution of Intel x86 and the ARM architecture. The Intel x86 has evolved over years, and from 29,000 transistors microprocessors, which was first produced, to Core Intel Core 2, which contains 820 million transistors. The organization and technology have changed dramatically over the years. One of the first invented Intel x86 was the 8080. 8080 world's first generation purpose microprocessor. It was issued. I'm going to briefly explain the evolution of the Intel x86 and the ARM architecture. The Intel x86 has been evolved over years from the 29,000 transistor microscopes microprocessors to 8086 that was first produced as a quadro-core Intel core, to which contains 820 million transistors. The organization technology have changed dramatically over the years, with their first development being the 8080 world's first general purpose microprocessor. This was an 8-bit machine with 8-bit data path to memory used in first personal computers. The other was the 8086 and was a 16-bit machine and was it was more powerful than the previous ones. It had a wider data path of 6 bits and large registers. It has real modes and an addressable memory of 1 MB. The other was the 80286 and it was an addressable memory of 16 megabits instead of just 1 MB for the previous ones, and two of the real mode and first generation 16-bit protected mode. The data transfer width was of 16-bit, which is more than those of the previous ones. The other was the 80386 and it was Intel's first 32-bit machine. It was able to compact against complexity and power microcomputers and maintain its maintenance. It was the first processor to support multitasking and contained 32-bit protected mode, an addressable memory of 4 GB, which is far more better in comparison to those of the previous x86 evolutions. The other was the 80486 and it was introduced on the concept of cache technology and instruction pipelining. It was offloaded, it used to offload complex math operations from the main CPU. This was something of very high quality and more better in terms of computer technology and processing. The other one is the Pentium. Among those of the x86 is the Pentium. This Pentium used super scalar technologies and was introduced as a multiple instruction, started executing in parallel. The other was the Pentium Pro and it used a register renaming, batch prediction, data flow analysis, speculative execution, among others. There was advanced speculative execution. Advanced optimization techniques in microcode were also added to level 2 code. The other was the Pentium 2, and the Pentium 2 was able to process video, audio, and graphics data efficiently by incorporating Intel MMX technology. There is the Pentium 3 and it contained SMD instructions and supports 3D graphics software. It has a maximum CPU clock rate of 1.4 GHz. There was the Pentium 4 and it implemented the third generation address translation that translates a 48-bit virtual memory. 48-bit. There was a virtual memory address to 48-bit physical memory address. The other was the core. The core was the first Intel microprocessor with a dual core, which is the implementation of two processors in a single chip, and there was the addition of visualization technology. The other was a Core 2 and it extends the architecture to 64-bit. Core 2 code provides 4 processors on a single chip. However, the x86 has some advantages in comparison to other technologies. The x86 was compatible in meaning it withholds process easily. its processing was much more faster than those of the other technologies. In performance, the x86 was more efficient and faster than the previous ones. It was versatile. In fact, it would carry out more tasks at a go. It was used on a broad industry base which supported large ecosystems and software and hardware vendors. Hence, of more advantage. However, it had some disadvantages. It had complex instruction set, which made it harder to debug software. Its power consumption became more and more, and it produced some more heat than those of the other technologies. Its cost was also high. There is the ARM architecture. The ARM architecture, it was previously known as an advanced RISC machine, but now it is the Archon RISC machine. Its family of reduced instruction set comparison to bucket RISC architectures for computer processors configured in various environments. The British computer manufacturers, the Archon computers, first developed the Archon RISC machine architecture in the 1980s to use in personal computers. Its first ARM-based products were core processors modules for the 650 to be based on BBC and Micro series of computers. After the successful BBC microcomputers, Archon computers considered how to move from relatively simple MOS technology 650 processors to address business workers such as IBM in 1981. The Archon-based computers ABC plan required a number of second processors be made to work with BBC microplatform, but processors e.g. Motorola 6800 and National Semiconductor 3216 were unsuitable. Yet 6502 was not powerful enough to graphic-based interface. The Archon RISC machine ARM2, the official Archon RISC machine project, it started in October 1983. The VSLI technology as the silicon patterner, as they were the source of ROMs and custom chips for the Archon. They implemented it with efficiency principles similar to that of 6502. The 6502 memory access architecture had let developers produce fast machines without costly. These machines were not costly, yet they were more faster than the previous ones. Memory access hardware was also improved, and the first sample of ARM silicon worked properly when they first tested it in 26 April 1985.